Hi students, so in this video I'm going to show you how to solve a problem on simply supported beams. This is the ninth question in the sample question paper published by BTech, which you will find on my website. And basically this is the diagram given. It's the ninth question, and what you have to do is calculate the reaction forces at point A and at point D. Now you are given various forces that act on this beam, and you have to find the reaction forces. So I'm going to show you how to go about solving this problem. Now what I want you to do is, as I solve this problem, you have to make notes for yourself. So basically solve this problem with me, and what will happen is when you will be revising for your exams, you will have notes ready which you can read and refer to before the exams. So here we go. So first of all, we start off by drawing a very rough diagram. Now this is going to be very rough and very as fast as possible. So that's A, B, C, and D with a slight overhang here, which is E. So you got our 5 points, and here you got simply pin support, and at D you have a roller support. Now if you want to know what is a pin support and a roller support, you have to go on my website, and I have provided links there which will explain to you what a pin, roller, and all different type of supports are. So that's distance 2, 2, 2, and 1. Here I have a force of 45 Newton at point B. At C I have 70 Newton. Also don't forget the units. Units are very important, because otherwise this 2 could be anything. And then you got a point D, which is a reaction force, and at point E you have a force of 20 Newton. Now there's another element that we have to consider, which is the uniformly distributed load of 35 Newton per meter. Now whenever you have a uniformly distributed load, what you got to do is find the net load on this beam because of the uniformly distributed load, and at what point it is acting at. So the net load because of the uniformly distributed load, and at what point at this beam it will be acting at. So how do we go about doing that? First of all, we find the net load, which is 35 times, now this is 35 Newton per meter, and my beam is 7 meters in length, so it is going to be times 7. So the net load is 245 Newton. And where exactly will it be acting? Whenever you have a uniformly distributed load, it always acts at the midpoint. So the midpoint of 7 is 3.5. So that's 2, 2 is going to be somewhere halfway around here, roughly. And what I'm going to do is use a different colored pen to show that this is what I have calculated. 3.5 and a load of 245 Newton. That's a 5, not a S, my bad. Now that we have all of the forces in place, now we find the reaction forces A and D, which are unknown. How do you go about finding it? So in order to find the reaction force D, you take moment of all the forces about point A. So what I'm going to do is consider a moment about point A. Please don't write on your iPad, it could damage it. Now moment of all forces, sum of all moments across A will be equal to, I'm going to write it down here because this space will not be enough. Sum of all moments across point A will be equal to, now what I'm going to do is consider all the forces and the distances, and before I solve this problem, in fact, I have to assign a sign convention. So any force going downwards will be positive, and hence upwards will be negative, right? So taking moments, first force is Ra, and it is going to be multiplied by the perpendicular distance. Now since it is at the same point, so my distance will be 0. Second force is 45 Newton, so that's 45 times distance is 2. Third force is 245 Newton at a distance of 3.5. Fourth force is the reaction force Rd, which is an unknown, hence I write Rd. That's going to be Ra, and it is going to be multiplied by 6. And the last force is 20, and it is going to be multiplied by 7. When I say perpendicular distance, it is literally the perpendicular distance, that's second, third and fourth perpendicular 90 degrees. Now I'm going to work out the sign convention. First force going downwards 45, oops my bad, Ra, going upwards, that's going to be minus. 45 goes downwards, so it is going to be plus. 245 goes downwards, hence plus. Rd going upwards, hence minus, and 20 going downwards, hence plus again. So now I'm going to rewrite this equation with all these expressions solved. So I might need my calculator for that. So Ra times 0 will be 0, plus 45 times 2 is 90, plus 245 times 3.5. Now this is a bit of a complicated expression. It's a good thing if you can solve it by in your mind, but it is better to use the calculator because you will not go wrong. So that's 245 point, that's 2 times 3.5, which will be equal to, in decimal, 857.5, minus, now you got Rd times 6. Now whenever you have a unknown or a variable times a constant, you always write the constant first. So 6 Rd plus 20 times 7 is, it is 140, but still I'm going to calculate it just to be sure. 140, always use the calculator, you will never go wrong. And that's my expression, moment of Ma. Now what we got to consider is this beam is in static equilibrium. What this means is it's stable, it will not move anywhere, and hence the moment is 0. I'm going to write it down. I want you to write this down with me because these are your notes, so it will help you understand things better. So since the beam is in static equilibrium, sum of all movements across point A will be 0, and hence this equation can be written as 0 equals to 90 plus 857.5 minus 6 Rd plus 140. Now looking at this question, I have gone wrong somewhere, and I hope that some of you have noted this problem, but if not, I'll tell you where I have gone wrong. While considering these forces, I did not take 70 Newton into consideration. So make sure that you do not make this mistake in your exam. Hence, always double check your work when you're solving it. You got 1, 2, 3, 4 and 5, 6 forces, and I have 1, 2, 3, 4, 5 expressions. That's the mistake. So what I'm going to do is correct my mistake, and in this step here I'm going to accommodate for my third force, that is fourth force. So first, second, third. So that's going to be 70 times perpendicular distance is 2 plus 2 is 4 meters. So that is 4 meters times 4. So this is the app by VenStudio that I use to access my website on the iPad. It's very easy and it is very clear, hence I use it. And your paper is in sample tests, sample paper 1 published by BTech. And I'm going to scroll to my problem. Yeah, there it is. Let me zoom in. Calculator. Now 70 times 4 is 280. That's going to be plus 280 because 70 is going downwards, plus 280 is on the same side of the equal to sign. Now what you see here is you have numbers, and that is constant numbers and one unknown, and hence I can use this equation to find the value of RD. So solving for RD, making RD my subject, I'm going to get all the numbers on one side and unknowns on the other. So $90 plus 857.5 plus 140 plus 280 will be equals to this minus 6 RD. When it goes on the other side of the equal to sign, it goes as positive 6 RD. Again, using my calculator, 90 plus 857.5 plus 140 plus 280 will be equal to 1367.5 equals to RD times 6, and hence my RD will be equals to 1367.5 over 6, because the 6 goes on the other side of the equal to sign, and my answer divided by 6 will be equal to 227.91. so RD will be equals to 227.91 Newton. Now you always remember, you only go to write it at with respect to 2 decimal places. You do not need to write the entire number, and hence I have written it up to 2 decimal places. It is 227.916. Hence when you round it up, the second digit here goes 92 in fact, because this third digit is more than 5. So my RD is 227.92. Now we can find the value of RA. And how do you do that? Now, because this entire system of forces is in equilibrium, all the forces acting downwards will be equal to all the forces acting upwards. Now the net forces acting downwards, 45, 245, 70 and 20. So forces acting downwards will be equal to 45 plus 245 plus 70 plus 20, and forces acting upwards is RA plus RD. Now since both of these are equal, that is upward forces equals to downward forces, (45 plus 245 plus 70 plus 20 will be equal to 380, will be equal to RA, which is RA now is RD, which is 220 RA, that goes RA plus RD we know, which is 227.92 Newton. So we don't need to write the Newton sign here, hence RA will be equals to 380 minus 227.92. RA will be equal to minus 227.92 in decimal form 152.08 Newton. Now the question we were asked was reaction forces RA and RD. So we have calculated here RD and RA. Now always highlight your answers correctly so that the examiner, when marking your paper, knows that you have correctly solved the reaction forces. Also, when you're practicing, try to write this in as little steps as possible. I have written so many steps because I have to explain this problem, but there are many cases where you can skip the steps. For example, this one here, and you don't need to write all of this. You can only write upward force equals to downward force, and then hence derive the value of RA, and this is the problem solved. And always make sure that you write your units, that's newtons here, Newton, RA, RD, all done.